are three types of free fall: dropping, throwing downward, and throwing upward. Today I'm going to teach you throwing upward with 15 meters per second. I'm going to show you 6 vectors. First one has a positive velocity with greater magnitude. The second one is also positive velocity but smaller magnitude, and the third one is almost zero but is still positive, approaching to zero. The fourth one is a negative, whose magnitude is equal to third vector but opposite in direction. The fifth one magnitude is equal to the second one but opposite in direction, and the sixth one magnitude is just like the first one but opposite in direction. So negative 15 meters per second. I allow our ball to move, to free fall under the influence of gravity for let's say 3 seconds. Initial velocity, you're going to create a table. Time, displacement, distance, velocity, speed, acceleration, and acceleration, magnitude of acceleration. And of course today, for because I don't want to use the calculator, so acceleration is going to be negative 10 meters per second square. We're going to use, instead of 9.8, we're going to use negative 10 meters per second square. All right, so let's start. Let's get started. So I'm going to put so let's start with 0. So at 0 second, at 1.5 second, at 3 second. So initial velocity is 15 meters per second, 15 meters per second, 15 meters per second. So 15 meters per second, what happened at 0 time, what happened at 1.5 second, what happened with 3 second. And of course, we're also going to draw it to understand what's actually going on here. So I throw the ball in the air. All right, so let's say this is location A, and this is location B, and this is location C. All right, so pay special attention what happened over here. So at location A, initial velocity is 15 meters per second. Okay, so initial velocity is 15 meters per second at location A. I throw the ball in the air with that much velocity, and the ball eventually go up, stop over here because it fight with acceleration due to gravity. What am I talking about when I say it fights with acceleration due to gravity? Here's what I'm talking about. So this is red, so this is a velocity vector. Let's see, I'm going to make acceleration blue. So this is the acceleration vector. So the red fight with the blue, okay, because acceleration vector is negative 9.8 meters per second every second. So it fight. So the red vector becomes smaller, and eventually 0. So the velocity over here is 0. Velocity at the top is 0. Okay, because it is fighting with the acceleration due to gravity. Okay, now the acceleration due to gravity always downward, and of course when the ball falls, its velocity is also downward. Okay, all right, so the final velocity would be equal in magnitude but opposite in direction. So at C final velocity would be negative 15 meters per second, which is equal in magnitude but opposite in direction. Why is that? Because this is totally symmetric, and that's what we're going to prove in this table. Okay, so the displacement, how do we calculate the displacement? There are many ways. I gave you a few formulas, but three formulas, three kinematics formula. So VF square is equal to VI square plus 2AD. Everything has the y direction today. dy is equal to VIT plus half AYT square, and VF is equal to VI plus AT. Okay, so this is the formula. Everything is at the y direction because we are talking about free fall, and free fall happens at the vertical direction. Okay, let's pay our attention back. So we're gonna use all three formula, but this is our important formula. So let's start with this one. So let's find the displacement. D is equal to VAT plus half AT square. So D is VAT, so initial velocity is 15 and time is 0. Oh, so then the displacement is 0. So at 0 second the displacement is 0, so I don't have to calculate it. Wow, that is smart. So now I'm going to find the displacement at 1.5 second. At 1.5 second, what happened? So velocity is 15, of course velocity is 15, 1.5 plus half, and I'm going to use the acceleration due to gravity is negative 10, so that I don't have to use the calculator. 1.5 square. So I have 11.25 minus 11.25. So D is 11.25. Displacement is 11.25. So yeah, displacement is 11.25. Okay. All right. So now at 3 second, what happened? 3 second, I expect. So what does that mean? At right here, from here to here. So this from here to here, it is 11.25. So 11.25. This one is positive 11.25. This one is negative 11.25. So the total displacement is 0 because the ball leaves my hand and comes back at the same height. It leaves say 1 meter above the ground. It comes back 1 meter of the ground. So it leaves the hand and lands the hand exactly at the same place. It leaves the hand and lands on the hand exactly the same place. Look what I mean. Okay, it leaves the hand 1 meter above the ground, lands on the hand 1 meter above the ground. So the displacement has to be 0. I will explain it graphically, and now I'm going to explain it mathematically when I say displacement is 0. So let's take a look. D is equal to VI. In this case, VI of course is 15. This one we are talking about 15, and time is 3 of course, plus a half negative 10 3 square. So D is equal to 45 minus 45. So the displacement is 0. Okay. So I said the displacement is 0, and you see displacement is 0. Of course, here is the understanding. So this is positive 11.25. From here to here is negative 11.25. So the total displacement is 0. Okay. All right. Okay, good. I'll give you a graphical understanding in a second. Now let's find the distance. The distance, when displacement is 0, distance is 0. When the displacement is 11.25, distance is 11.25. From here to here is 11.25, and here to here is 11.25, so is 22.5. So total distance the ball travel is 22.5, because 11.25 plus 11.25, that's 22.5. 11.25 minus 11.25, 0, and that was the displacement. So don't get mixed up with displacement and distance. It's a big deal. Okay, now we're gonna get the velocity. Velocity at 0 second. Velocity is at 0 second is not 0, because right after the fraction of a 0 second, I'm gonna be little loud so that you wake up and you listen. Right after the fraction of a 0 second, velocity is 15 meters per second, because that's the initial velocity you put on the ball. So the ball is start taking off and going to the air. Velocity is 0, coming back to the hand. Okay, so 15, of course. Velocity at 1.5 second. I don't know velocity at 1.5 second, but I do. I said that velocity at 1.5 second is 0 at the top. So velocity at the top is 0. Now let's prove that. Vf is equal to Vi plus At. I'm using this formula right now. Okay, so Vf is equal to Vi is 15 plus negative 10 times 1.5. So Vf is 15 minus 15. So velocity at the top is 0. I said that. Why 0? It has to make sense because graphically the velocity vector fight with the acceleration vector. When you are fighting with acceleration vector, you lose. If you don't lose, escape velocity, and then you go and hit the and become the satellite of Earth. But that's not what's happening over here. I'm applying only 15 meters per second. That's not escape velocity. Earth escape velocity is more than 11,000 meters per second. Okay, so but I apply only 15 meters per second. 15 meters per second is less than 15 meters per second is less than 11,000 meters per second. Of course, the Earth escape velocity is little more than 11,000. I think it's 11,182 meters per second. That's what Earth escape velocity. If you can jump up with initial velocity more than 11,182 meters per second, you go up, and you never come down because this velocity will never be zero. This velocity will never be zero. But I apply how much? I apply only 15 meters per second. That means this velocity vector will lose with the blue acceleration vector. Okay, because this velocity is very small compared to the escape velocity of the Earth. You get it? Okay. Now I said that this one is negative 15. Now let's prove that. So VF is equal to VI plus AT. So VF is equal to VI, of course, is 15 plus negative 10 times 3 seconds. Okay, so VF is 15 minus 30. So VF is negative 15. So that's the reason this is negative 15. Why negative 15? Is because this has to be equal in magnitude but opposite in direction. Okay. So velocity over here is 0. Velocity at 1.5 seconds is 0. And velocity is negative 15 over here. Okay, good. Speed 15. Speed over here is 0. Speed over here positive 15. Now this one is very easy. Negative 10, negative 10, negative 10, and 10, 10, and 10. Okay, now I'm going to draw dt, vt, and at graph. Pay attention over here because this is vt graph, and vt graph is very important. Area under vt graph is the displacement. So what do we mean? So this is what I mean. So I'm going to make it green. So area under vt graph is the displacement. Okay, so this green and this blue. So area under vt graph is displacement. Okay. This is my dt. This is my vt. And AT is easy, so I'm just gonna not paying too much attention to AT. So AT would be easy. Okay. So the dt, displacement versus time, velocity versus time, and acceleration versus time. Okay, good. So this is 0 second, this is 1.5, and this is 3 second. This is 0 second, this is 1.5, and this is 3 second. This is 0 second, this is 1.5, and this is 3 second. Okay, good. Now 1.5, I think I can write a little better. 1.5. Okay, good. So at 0 second, displacement is 0. That's good. Okay. At 1.5 second, displacement is 11. This is 11.25. So let's say this is 11.25. Okay. So 11.25 is right here. Okay. And at 3 second, displacement is 0. So this all add up. So right here, and right here. So you just connect this 3 dot. All right. So this is the displacement versus time graph of the ball you just throw in the air. It leaps 1 meter above the ground, and it lands 1 meter above the ground. On another word, it lands on the exactly same height it leaves. Okay, good. This is the velocity. This is the distance versus time graph. Now we're going to convert it to the velocity versus time graph. All right. So let's see. So the velocity, what is the velocity? Initial velocity is 15. What is the final velocity? Is negative 15. Okay. All right. So at 0 second, at 0 second, the velocity is 15. So that's what I'm gonna do. Velocity 15. At 1.5 second, the velocity is 0. At 1.5 second, the velocity is 0. All right. In this graph, the velocity is 0 right here. In this graph, velocity is 0 right here. Okay. It should make sense. At 3 second, the velocity is negative 15. At 3 second, the velocity is negative 15. Okay. So, all right. Very nice. Now, we're going to do the acceleration graph. Acceleration graph is very easy. Acceleration graph is at 0 second. At 0 second, the acceleration is negative 10. So let's say this is negative 10. At 1.5 second, acceleration is negative 10. Okay, so this is negative 10. And at 3 second acceleration, so acceleration is the same. Okay, good. Now I'm going to come back over here and I'm going to pay attention over here because this is VT graph, and VT graph is very important. Area under VT graph is the displacement. So what do we mean? So this is what I mean. So I'm going to make it green. So area under VT graph is the displacement. Okay, so this green and this blue. So area under VT graph is the displacement. Okay, so what do we mean? So let's first find the blue area. And I already know what is blue area. Blue area is 11.25. Where did I write 11.25? 11.25. And what is the green area? Is negative 11.25. Okay, so blue area minus green area is 0. That's why the displacement is 0. And the blue area plus green area is 22.5. That's why the distance is 22.5. Those of you who did not understand the math should understand now, because visually this make more sense. So let's first do the blue area. The area is half BH. So then area is half B is, so the base is 1.5. So 1.5 and height is 15. Okay, so 25. Okay, so this is 11.25. Now we're going to calculate this one. I'm going to use the, of course, green. So I'm going to calculate this one. So half BH. So half B is the base. So the B is here is 1.5. And H is the height. Height is negative 15. So it's negative 1.5. Negative 11.25. Okay. All right. So what does that mean? So I forgot to put negative. Okay. So positive 11.5, negative 11.5, displacement is 0. Positive 11.5, because since this is negative, you take the absolute value, you make it positive 11.25. That's 22.5. That's the total distance. Total distance is blue plus green. Total displacement is blue minus green. Okay, get it? We're going to use another formula to do that. Long time ago, you saw me using this formula many times. So displacement is equal to average velocity times elapsed time. Average velocity formula I gave you many times. Now it comes handy. V plus V naught over 2. So displacement is V plus V naught over 2 times elapsed time. Okay, so what is V? V is very simple. V is 15 and V naught is 0 over 2 times elapsed time is 1.5 elapsed time for the blue. So this is 11.25. Now we're going to do the other one. So now other one is, of course, same formula, times delta t. So this is V plus V naught over 2 times delta t. V is what? What is the V? B is 50, B is 0. B is negative 15 plus V initial is 0 over 2, and elapsed time is here 1.5. and that is negative 11.25. So there is hundreds of ways you can do the same thing. Okay, so hopefully you understand this. If you understand this, that means you are in good shape. Next time you're going to do the physics when you throw something down.